Hello, everybody. This is Andy Ellicott from Swarm 64, and I want to thank you for joining us today to learn about open source data warehousing on the Postgres database. Our agenda today begins with a discussion about modernizing data warehouses and analytics with open source, reasons for doing that, and what types of projects make sense to move on to open source data platforms like Postgres. We'll also talk about extensions to Postgres that make this possible to handle the query-intensive workloads with larger data sets and more complex queries, and go through different data warehousing and analytic use cases that make sense for open source Postgres. We'll also talk about implementation strategies, both for new analytics projects and also for projects that might involve migrating an existing workload off of a legacy data warehouse like Oracle or DB2. There will be time for questions at the end. If you have questions, please just enter those into the questions panel and go to webinar. One of the most popular questions is whether there will be a recording of this webinar and whether slides can be shared. The answer to both of those is yes. We'll send you an email probably within 24 hours with links to a recording of this event and also a copy of the slide deck. Okay. So the reason we're talking about this is, among other reasons, is that industry experts and advisors, Gartner Research, late last year published a report on an outlook on open source databases, and they made a couple of predictions. Number one was that they predicted by the year 2022, 70% of all database projects would be running on open source databases. And they also predicted that by 2022, 50% of all of the database projects that are already built and running at the end of 2019 on commercial non-open source databases would be migrated to open source. Okay, so and if you're a database technologist, you know that one of the biggest cost-saving opportunities is probably the analytic or data warehousing databases. The platforms like Netezza, Oracle, DB2, Teradata, even some of the newer, older, newer legacy analytic databases like Vertica and Greenplum. They're very expensive. You know, it's the annual maintenance alone on something like a Netezza or an Oracle Exadata can cost anywhere from $250,000 to $1 million US just for maintenance. And a lot of companies, we run into large enterprises, kind of Fortune 500 companies will have, it's not uncommon to see them having, with 50 to 100 Netezza racks, right? So the opportunity to save money by moving workloads off of these legacy platforms onto open source, free open source database platforms like Postgres is really, really high, okay? And that's why we feel like it's hero time for a lot of you inside enterprises or who provide consulting services to them. Really help companies save millions per year in IT costs by moving workloads off of those legacy platforms, right, and onto free database platforms like Postgres. Okay, so that's our topic today, and we've got two great experts to share their thoughts and experiences on this. Hans-Jürgen from CYBERTEC and Thomas Richter from Swarm 64. And without further ado, let me turn things over to Hans. We'll kick this off. Hans?
So, hello everyone. Thank you for joining up. My name is Hans-Jürgen Schönig. I'm the CEO of CYBERTEC. Can you go to the next slide, please? Yeah, thank you. So we are a database company focusing on Postgres for over 20 years. So we provide 24/7 support for Postgres. We do training, consultancy, performance tuning, and clustering. And we're also doing a fair amount of data science related projects. such as machine learning, artificial intelligence, big data, data mining, etc. So we are basically a data company focusing on large amounts of data. We are a very international company. Our headquarters are in Austria, but we also got offices in Uruguay for the Latin American market, in Johannesburg, in Mauritius, in Switzerland, in Poland, as well as in Estonia. So our customers are, as you might know some of them, such as Amazon, United Nations, Skype, HP, etc. So name any industry, they're going to be customers using open source or focusing on open source technology. So basically, we're all there. So there are many big names which have already adopted open source. I mean, there's nothing bigger than Amazon, I would say, and also companies such as BMW, very well known. So why analytics? That's an important question. I mean, the reason behind all those data warehouses is not that they are having some, mandatory legal background, but they have to serve a purpose, right? And in order to serve a purpose, we should look at the top companies of the last 10 years in order to figure out why technology and why machine learning, analytics, data warehousing, high performance data warehousing with Swarm, etc., really matters. So if we look at the top companies in 2006, what you see is that the biggest company was ExxonMobil, second biggest one, General Electric, etc. And if you just take this time span of 10 years, which is nothing, basically, you will see that basically all the data companies have taken over. So you see Apple, Microsoft, etc. So basically all the tech companies have taken over. So all this traditional, oil business, etc. So regarding market cap, it's really the data companies that are running the show these days. Top brand names 2020, it's Amazon, Google, Apple, Microsoft, Samsung, Facebook. There is basically everything is a data company there. And as I keep saying, everything is about data, everything else is second class. So data and steel are not going to rebound. It's not going to be the gravel companies or the dishwasher companies who are going to rule the market in 2030. It's going to be the data companies, right? So in other words, data is the new oil. That's the way I want to put it. And if we look at the amount of data we are looking at the moment, what you basically see is an exponential curve pointing upwards, just basically showing that data keeps growing. So in 10 years from now, there's certainly going to be more data and certainly not going to be less data. So it's definitely the right decision to focus on this entire data infrastructure if you want to be one of the winners and not one of the losers, right? So how can we reach the promised land? So obviously it makes sense to make use of data. So the question is, how can we get there, right? And the first thing you should really keep in mind is that in order to get there, the first thing to do is just think about it, right? Think about it. What data do you have? How can you concentrate your data in order to create information? And secondly, how can you be more realistic about your expectations? You have to keep in mind that unexpected stuff is going to happen. I'm going to tell you a bit later about a bit more about it later. And at the end of the day, it's all about the end user. You're not creating data because it's funny to read it in the morning, because you do that for the end user, right? So things to think about data and things to avoid. I've been in, as I said, in database business for 20 plus years, and I can tell you one thing: it's the single biggest destruction of value is if you do update or delete, right? So if you delete your data because you don't want to purchase a 50 euro hard drive, you're basically destroying hundreds and thousands and maybe millions of euros or dollars worth of data just because you didn't want to keep it, right? with people who were in control of GPS tracks for thousands and thousands of cars, and they didn't want to store them because nobody had the imagination what could be done with this data in order to be beneficial, right? So in other words, store data, make use of data, don't destroy it, right? Next slide, please. Thank you. So in order to make proper analysis, usually it's better to have more data than less data. And it's also important that you think about quality. I mean, I saw data sets which were just a compilation of crap, like interest rates written out in text and things like that. So important thing is quality does matter, amount of data does matter, and not sure I've mentioned it's about data. So obviously you've got to store it and keep it in a sane way. What is important when we're talking about AI projects is basically to expect unexpected insights. I was talking to a guy the other day in my area, and they were analyzing data from elevators because they wanted to do predictive maintenance. They wanted to figure out when is this thing going to break. And what they figured out basically by chance is that by analyzing the data coming from the elevators, they could predict with a certain likelihood that somebody is going to leave his office building. And so if you're running a large apartment or a large office building, basically the movements of your elevator can already tell you that somebody is going to give up his office, right? So you maybe if you can just increase the efficiency of your building by 1% by renting out earlier, you're already onto a big winner, right? The other thing which was quite unexpected was in agriculture. So imagine you got a tractor, you're plowing your field, and you figure out that, hey, if we go east to west instead of north to south, our yields are going to increase 3%, right? So those are all things which you might be able to figure out by looking at the data. Final example, we were looking at hotel prices in Vienna to figure out that, let's say, if there are events, etc. So what's the sweet spot? And we figured out that there is no sweet spot because everybody's just copying the price from the neighbors, right? So there are many things you wouldn't expect, but that's the whole point of it, I would say, that you should prepare for the unexpected because that's basically what you're looking for here. Finally, as I said before, don't do it because all your friends do it. That's not the main idea, because usually that's not going to end very well. Really focus on stuff that's going to speed up your processes. You want to gain more information, or as we keep saying, is you want to turn data into useful information. And finally, it's about suggesting better products, having better answers, and that's basically the key to being more valuable and to have a better product. Because if you make slightly better predictions, I mean, it's certainly going to be more likely that people are going to purchase more in your shop or whatever it might be. And in some cases, it's also about responses, right? So if you response time, so if you can give a customer information in seconds, it's certainly a better user experience than going to some government bureaucrat who needs 6 months to sign a paper, right? So let me hand over.
Hi, yeah, as said, I'm Thomas Richter, CEO of Swarm64, and I will talk a little bit more about Postgres in the context of data warehousing. And well, Postgres, I think, needs no further introduction, extremely well known for transactional workloads, systems of record, systems of engagement. Yet what is really not a very common case for Postgres yet is systems of analysis, or OLAP, OLAP databases. And that is somewhat strange, because if you're looking at some of the famous data warehouses built in the last 20 odd years, you will see cases like Netezza, cases like Greenplum, or cases like Amazon Redshift, which all have been built off the Postgres code base with heavy modifications. One thing all these solutions also have in common is that they actually went away from the Postgres code base. So they took things, made it proprietary code, and turned it into a new solution. That's why Postgres in itself didn't actually get these features, but instead they were delivered as new products. Now, let's look at what Postgres would need for data warehousing. On the one side, you need better query planning. Whenever you want to run a very heavily parallel load, whenever you're running workloads that are not just dereferencing some indexes, you need to plan differently. You need to think about parallelism. How much does it cost me to set up? How much do I deploy? And this is, by the way, one of the reasons why Postgres for quite a while had not been a very viable choice for data warehousing. Parallelism was really added late. And while those solutions like Amazon Redshift I've mentioned, like Netezza, etc., were built, they, as one of the first things, added parallelism and added a parallelism-focused planning. So Postgres needs better planning with a very strong mindset on parallelism. You need some means of moving the data quickly into your processing and through your processing. So this is where, in the Swarm64 case, columnar indexing comes to play. And then, of course, you need to execute queries that go through billions and billions of rows fast. So interestingly, these requirements match what Swarm64 has offered to Postgres as an extension. So instead of going away, building a new product, we decided to actually extend the existing open source product. And the benefits are multiple. Number one is we're not taking away, we're giving. We're not only developing the extensions, we're also actively contributing to the community. Secondly, we can work with partners like SYBERTEC to offer really a best of both worlds, a Postgres that is powerful enough to do data warehousing activities. And thirdly, most importantly, is it really gives you as a potential customer a ton of flexibility in terms of how you want to deploy it and how you want to use it on premises, in the cloud, with all sorts of different support arrangements. It's all possible. And well, I mean, our reason of existence is, of course, to give you much faster response time on your complex queries, on your complex workloads, so you actually get a true benefit that allows you to compete with some of the best data warehousing solutions there are on the market. Let me do a little bit of a deep dive on how we do that. So in the blue box, you have Postgres itself. We are 100% Postgres interface, which means all these wonderful things that you have still work, like tools around in the Postgres ecosystem, like certain mechanisms that you already are familiar with and are already using heavily in your enterprise IT. All these things keep running. What we do is we use the inbuilt extension mechanisms to add things to it. And adding in this case means not taking away. It actually means that Postgres has a choice to use these things when they come in useful, but Postgres doesn't get any of its other features deactivated, meaning you've got a full variety now of features that Postgres can all use at the same time without competing with each other. Which brings me to the first subject, query planning. Query planning is essential because it not only is like query planning on itself, I'm sure you have made that experience, can very often be the single most dominant factor in how fast a query executes. The query plan can often make a difference of 1 to 100. An effective query plan could be 100 times faster than an ineffective query plan. But query planning also gives the chance to offer all these additional mechanisms like data access and query execution, which I will be talking about in a moment. And Postgres can choose. Maybe there's a query coming in that is very small. It will just look up in a classical B-tree index, and it will find the value very quickly. Or a query comes in that is very complex. then it will possibly use all of the Swarm64 features to answer that query quickly. In this planner, we also make costing improvements, especially for those OLAP queries, those analytical queries. And we also have a means to keep your statistics up to date. Again, probably a experience you also made is if your statistics are wrong, the plan chosen may be very ineffective. And if the plan chosen is very ineffective, your query may actually be very slow. Let's look at the second part, data access. We do, or one core observation is that if you cannot move the data fast enough into the processing chain, you will not see an acceleration. And we thought one of the very attractive ways on how this is solved is with a column store index. A column store index is a well-established concept. I think maybe the most famous one is the Microsoft SQL Server columnar index. And Swarm64 has built, through Postgres extensible indexing interface, a complete compressed column store index that is also transaction safe. And it allows you to skip the irrelevant data during a query, so it reads a lot less, and what it does read is also heavily compressed, which as a result means that you're only going to access a 10th up to 100th of the I/O you would normally do if you, for example, were to do a regular table scan. So for the cases where a B-tree index, a classical kind of point lookup index, doesn't quite cut it, the column store indexes are extremely powerful. So whenever you, for example, have to run larger queries, table scans, bigger aggregates, things like that, it makes a day and night difference. Finally, if you're going through billions of rows, and I think that's the scale we're talking about here. It's like we're talking about billions of rows. We're talking about large data sets. We're talking about many concurrent users accessing rows at the same time. It is important that all the processing through the stream is very effective. We found that joining billions of rows can be a real challenge. It can sometimes already be a challenge joining millions of rows. So Swarm64 has added a specific join type or specific join types that can be chosen to join together larger data sets very effectively and with a high degree of parallelism. In fact, the whole more parallelism during query execution is one of the important features in Swarm64. And finally, parallelism is often blocked by things like data distribution and data movement. You need to shuffle your data, move it between different execution nodes effectively in order to keep parallelism active. And you need to optimize the movement of data in between processing steps. Let's look at this in a little more detail. Here we've got a very regular query. So when we mean complex queries, this is what we're talking about. You're scanning and filtering a couple of tables, you're joining them. Maybe you have a unique constraint or something similar. Maybe you want to see an aggregate, then you're joining the aggregates maybe with another table. And then in the end, you're sorting everything and you're kind of picking the top 10. It would be very classical query, right? Now, if you see on the left-hand side, Postgres would execute that fairly well, but Postgres would take minutes. And there's a couple of reasons for that. Number one is the parallelism applied is not so high. And then certain conditions, for example, distinct, etc., would actually turn a parallel query plan very quickly into a serial query plan. On the other side, you've got Swarm64, where we actually start with a much higher degree of parallelism. So you see many more small boxes there next to each other. And we're actually pushing through this execution pipeline very quickly, needing less RAM in the process, distributing things in between with our shuffle node. So you can actually no longer, you don't have to go serial from parallel at the point where, for example, the distinct condition comes in. And we essentially keep the query parallel for as long as possible. And that moves you from minutes of execution time to seconds of execution time. Why do you care? Well, I think it's okay to run a query and to get a cup of coffee. But if you run the next query, you don't want to get a cup of coffee again, right? We are used to be able to work with the system, get snappy responses. if you're trying to do your work and your system constantly lets you wait, it's no longer fun, it is no longer productive. And we all know the users, the knowledge workers that are trying to find out, for example, from the elevator movements, if someone is leaving the office building, or vice versa, if they need to do predictive maintenance. The people analyzing this, they are not cheap. So we want to make sure that their time can be used productively. Hence, we need something in the second range, not in the minute range. I will do a small deep dive on the column store index because, again, this doesn't only help you in the context of the overall query processing of complex queries, it also really helps you to avoid table scans. There is this concept of over-indexing, right? That if you put a B-tree index on every single column in your table, it may help you, it may save you sometimes, but it is also very expensive to constantly maintain. B-tree indexes are good for certain things, but it is kind of driving things a little bit to the absurd to put them on everything. The column store index is really quite different. So for starters, it is heavily compressed. We support different compression parameters. You can even go, you can not only define which compression algorithm. For example, one of the ones I would recommend is Z standard, extremely powerful compression algorithm, which we also support. You can also choose more lightweight options like LZ4, although Z standard is extremely powerful versus the few CPU resources it needs. So it not only heavily compresses the data, it also packs it in a way that compression ratios can be even higher. And you also do not have to define a column store index for every column in your table. You may skip some obvious columns, like, for example, a text column containing a comment, something like that. That's not typically something on which you would do a lot of queries. So you would probably be a little bit selective. So column store index, easy to define, one line, and it does keep up in the background. It is transaction safe, and it is a lot more lightweight than maintaining multiple B-tree indexes containing all these columns. Much more compact, much more lightweight. So how does it work? Well, as you see at the bottom there, you create your table, then you create your index, very standard syntax. And then what you will see on the right-hand side in the query plan is that it actually then scans the heavily parallel scan that is also using only compressed data, so much less access time and much faster query processing. Helps you, as said, with those complex queries we went through in detail before, but it also helps you if occasionally you need to do a table scan. So adding a few of those column store indexes, in particular to your larger tables, is really a very, very easy, very quick way to see a very, very different speed in your database processing. Okay, let's go to the next slide. Let's look at how this actually articulates itself in the real world. So TPCH, pretty well understood benchmark. We have a model here. This is a benchmark modeling a data warehouse of a classical kind of manufacturing and selling company. So they have their orders coming in and they're serving them, and they have different product lines, and they're basically selling this across the nation and so on. Really just modeled after classical star schema type data warehouses. And the challenge quickly becomes that when you move into, this is at a scale of about 1 terabyte of raw data. So as you move to a scale of 1 terabyte of raw data, Postgres starts to really struggle, and you're moving into timeout category. And timeout really means 15 minutes and the query doesn't come back. I mean, who is ready to wait for hours for queries to come back? On the other hand, you've got Swarm 64. You define a few column store indexes, and off you go. Not only does it finish all 22 queries in less than 15 minutes, it in fact finishes all 22 queries in 80 seconds or less. And this is on a very standard, off-the-shelf 2 height unit servers. So very easy to obtain. Why is this important? Because it shows how capable Postgres can be with the right extensions. You're moving into territory that allows you to get a quick answer to your question without much fuss. To define these column store indexes is really just a few lines of SQL. And if you're interested, there is a full benchmarking toolkit where we have, for example, published our way of running TPCH on GitHub, where you can also see how it is done. Next slide. On the other hand, if you don't have to scan a full table, but instead can read a few select columns from a column store index, you will tremendously lower your I/O. If your joins are very effective, they will significantly reduce the RAM consumption. If your processing is more resource efficient, which PostgreSQL processing is, you will spend fewer CPU cycles. Now you can also turn this equation on its head, meaning that if you have a Postgres-based data warehouse, data mart reporting system, maybe Postgres-based read replica, how many users can that support? Well, with Swarm64, it can actually support significantly more users because on every single query, a lot fewer resources are used. On average, it's about a factor 4. We're using a factor 4 fewer resources. That means we can concurrently support 4 times as many users at the same time. So yes, there's an argument for speed, but there's also an argument for concurrency, meaning that instead of 10 analysts working on your system, you can support 40 analysts working on your system, and they will still get a good query execution time that meets the service level agreement. Next slide, please. So this is a analysis we did in a healthcare context where we had a teaser replacement, and there we ran against a highly optimized legacy set of queries. And the point about the legacy set of queries was really they were specifically optimized for the system. And then against that, we have Swarm64 coming out on a smaller system, no optimization done whatsoever, and it out of the box did pretty well. Yes, certain queries we were slower, as you can see there. Certain queries we were faster, but everything was within the second range. So you take Netezza on the one side, highly proprietary, and you take open source Postgres with the extension of Swarm64, and out of the box, it does really well on the queries that you've before spent forever optimizing for your Netezza system. So that, I think, is a really nice A/B comparison that makes migration easy, because you no longer have to fear, when I move from Netezza to Postgres, do I need to anticipate a huge performance loss that I need to design around? No, you can run data warehouses on Postgres.
Oh, thank you, Thomas, for the introduction to column store index. I can only confirm what you said. It's exactly what people are observing in the real life. And in order to give some weight to what you just mentioned, I want to give some use cases to show what this exciting technology can be used for. As I said, we've been doing Postgres for 20 years, and we've seen quite some challenges. And therefore, let me guide you through some practical examples, as you might see them on the screen, and see how Postgres and Swarm64 can help you to run those things more efficiently. So, okay, so first use case, which I came across for the first time, I think something like 15 years ago, is fraud detection. It's one of the classical use cases, and basically what you're doing is you have huge amounts of data, and in most cases you have no clue what you're looking for. So in many cases, this entire fraud detection stuff is you can of course automate a lot of it, but in some cases you just have no clue what you're looking for, and you basically have to dig for a lot of data to detect anomalies. and then basically try to make assessments in real time. And this is especially when this response time things starts to be relevant, because you don't have infinite time in order to detect fraud cases in most situations. So it's this whole topic of having more data active at the same time and being able to process it is super important. Okay, so next slide, please. So the benefits we got here are really super important. So first of all, as I said before, faster response time, find data more quickly, which also means that it can react more quickly. I recently had a case where it was about child abduction, and there they're talking about the golden hour. So the first hour which allows you to succeed or fail in case something bad happens. And of course, you can only process a lot of data if you're going for parallelism, and if you can feed data to your algorithms more quickly. So prepare the data more efficiently, filter the data more efficiently in order to pass it on to the next layer, which is then going to hopefully make some clever decisions here. The next example I would like to focus on is dynamic pricing. Okay, so suppose you're running some sort of company, and by some miracle, you might be able to charge 10% more for some product just because you're doing it a more efficient way, you're making more clever predictions, you're doing some more clever real-time pricing. What I want to focus on here is that a small benefit can really give you a major boost. So suppose you're increasing prices by 10% because it's done in a more clever way. It can basically mean that your profits can go up 30%, right? Because your costs stay the same, everything stays the same. You just happen to pocket more money. So a small increase in some area can give you a major boost. Can give you a major boost for your bottom line, right? So, and of course there are some other positive side effects, like you can optimize workloads or whatever. But just want to really point out a small improvement by just having more data, being more efficient, have better response time, can not just give you a small improvement on the bottom line, it can give you a major boost. And what Swarm can do for you in this area, if we go to the next slide maybe, it can really give you more real-time capability, right? So if we're talking about dynamic pricing, if we're talking about dynamic suggestions, it's always real-time, response time, amount of data. And once you're done with your sales, or once you're done with your time series, or once you're done with your fertilizer allocation, or whatever you want to do, of course, by processing more data, it's also more efficient on the exposed analysis side. So it's not just something which is going to help you with your business at the moment, it's also going to help you in order to improve things afterwards. So, which brings me to product recommendations. If you're a salesperson, you're working in some shop, you can basically recommend a product to a client. So you're talking to somebody, you make a recommendation. But if you're dealing with hundreds of thousands of products, how would you basically make clever recommendations for each of them? So you cannot do that manually anymore. Nobody can dig for 100,000 products manually. Nobody can dig, tag them, recommend them, add stuff. So what you really want to do this machine-driven, not human-driven, and which allows you not to do emotional decisions, but it allows you to do data-driven decisions, which are, of course, usually ways more efficient than what any human can ever deliver. Machines make statistically correct results. Human make subjective judgments, right? So just by being able to process these amounts of data more efficiently, you're basically already on the golden side. And if you go to the next slide, the benefits are obvious. It always boils down to the same thing. I really want to drive this home. So larger analysis, more data, less hardware, lower costs, faster response times. So that's the key there. And there is really no point these days in just burning millions on some legacy warehouse or whatever, just just because, right? So that's certainly not going to be state of the art. So the main question I want to focus on is, so how can you get there? So how can you move from legacy DB2, legacy Oracle, legacy Nidata, etc., to a better situation, to a more modern environment, etc. So first thing, of course, you want to assess the situation. And then if you're, let's say, on Oracle, and if there's a lot of stored procedure code, this stuff has to be converted. So there are a couple of solutions we can offer you there, which is automatic code rewrite, etc., in order to facilitate the change faster. Of course, you want to adapt the code of your application, and finally, you want to make sure there is proper 24/7 support in place, there is expertise around, etc., etc. Okay. So what we can offer in this area is basically we can help you with this data warehousing analytics, machine learning, etc. But of course, our background is to be database engineers. We've done Postgres since 1999, so we have a lot of Postgres experience. And I'm not standing here because I got paid. I'm standing here because I strongly believe in this column store technology. I mean, this is revolutionary for data science. This is revolutionary for data warehousing. It's not just some extension. In my judgment, it's the extension for Postgres, right? So this is, I would say, definitely something you should investigate. So when you're talking about migration in general, and let me focus a bit more on Oracle here. What is really important for Oracle people is mostly, you know, this null handling stuff to make sure that you have all those Oracle specifics covered. And what is also important, if you're running a 5 GB database, downtime is not an issue, right? So downtime starts to be an issue if your systems are really, really large. So if you want to migrate 100 terabyte database, if you want to migrate 50 terabyte database, if you want to migrate 200 terabytes of data, even copying this stuff is going to be massive already. So just to give you a number, if you can copy data at a rate of 1 gigabyte per second, a terabyte is still going to take 20 minutes. So just imagine what it means for 100 terabytes if you're copying at 1 gigabyte a second. So this zero downtime migration thing is really important, and especially for large system, we have to keep that in mind, right? So what we are doing on the SYBERTEC side, which is on the next slide, we help you to migrate your data structures, and we can certainly help you to move over data more efficiently. So what we got here is, there's a typo on the slide. We had a migration recently for an Austrian financial organization, and what we managed was 1.5 gigabytes per second. So not 500 gigabytes per second, obviously typo. So we were talking about the transfer rate during migration from Oracle to Postgres of 1.5 gigabytes per second. We were basically bound by the amount of data Oracle could give us. What the thing is going to migrate is indexes, constraints, foreign keys. But what I really want to point out is we can migrate stored procedures, automatic code rewrite, and we also got means by hooking up to the Oracle log miner, which gives us zero downtime migration by doing change capture during the migration. Okay, so while you're copying over, you're still running on the old system, but the new system is already getting all the changes which are necessary in order to switch over quickly and to sync the machines within minutes, and basically avoiding days or hours or maybe even weeks of downtime here, just because of the sheer amount of data. So on the next slide, what you see, basically it's a graphical tool which allows you to facilitate this migration. What we do is we hook up to the Oracle system catalog. We turn it into the Postgres representation without actually parsing all this great table stuff. So we really hook up directly to the system tables, fetch the data over, and do it in the most efficient way possible. Right? So moving tables and data, what happens here is quite seriously a complete migration tool chain. It's a graphical tool. It works for Oracle. We're currently adding support for DB2, Sybase, and MS SQL. So we really want this to be comprehensive. For Oracle, we can basically provide code rewrite. For DB2, Oracle, and maybe SQL Server, we can go for zero downtime migration. So certainly possible for Oracle and DB2, and it's already available, of course. And yeah, for the other databases, we keep adding features to the migration tool chain so that we can be as comprehensive as humanly possible here. So finally, you have to see that a migration is not as easy as it might seem. It's not just copying over. We have to keep in mind that in Postgres, we have many more data types than say Oracle. So we're talking about 97 data types in standard Postgres. So that was the number I saw when I checked it last times. But then there are even more data types if you add extensions like PostGIS or CI text or vector types and things like that. Okay. For moving indexes, we also have to keep in mind that Postgres supports a lot more different types of indexes than other databases, Swarm being one of them. So the migration toolchain also gives you the opportunity to see this whole migration process as a cleanup, as a chance for cleanup. So if you got some, dirty data structures, if you got, too many columns, wrong data types, whatever, the migration toolchain already gives it a chance to do the cleanup, right? So to transform the data as we speak and provide it in a way that the Swarm is going to be even more efficient as if you would just go for, let's say, standard numeric types, etc., right? Or number. So as far as our services are concerned, what we got here, as I said, is a migration toolchain. So we obviously help you with the migration. We provide 24/7 support for aftercare, etc. And finally, I want to point out that there is a thing called Postgres Enterprise Edition, which happens to be on the next slide. And it really comes with a lot more additional stuff. So first of all, the full Enterprise Edition is by default Swarm 64 enabled, but it also comes with some additional add-ons to Postgres, including data obfuscation, so GDPR, privacy, etc. Those are all issues companies got to deal with these days. So we got the data obfuscation in there so that the data scientists can see data that is statistically like the original data, but which is obfuscated, just randomized email addresses and stuff like that. Then Postgres Enterprise Edition, the full Swarm enabled stuff, is coming with full on-disk encryption, and we also got an internal module which helps you to do some anomaly detection for intrusions and some more additional features. So this is certainly something, if you look for a licensed product, Postgres Enterprise Edition is what you're looking for. And as I said, we provide 24/7 support worldwide. It has enhanced security, performance monitoring, and is Swarm enabled. So with those words, I want to hand you over to my colleagues. And I want to say thank you on behalf of CYBERTEC, and thank you for your attention, and thank you for showing up.
Thank you, Hans. So yeah, we'll take some questions now. We have a few already. We're getting near the end of the hour. For those of you who are already using Postgres and want to try Swarm, you can install Swarm into Postgres 11 and 12 databases, version 11 and 12. runs in the data center or on the cloud, and the development license is free if you want to start developing with it today, try it out. But let's take some questions. There are a few already. Firstly, for Thomas, I think, question is, does the column store index support expressions? For example, can you index an element from that's in a JSON object, a Postgres JSON object?
So in terms of the objects you can index in the column store index, we on purpose went for all different Postgres types. Everything that is not toasted, as in stored out of the regular heap table pages, can be stored in the column store index. And as a result, you can actually take your JSON and put it into your column store index, and then the function will actually be run only on the JSON itself. You can also, of course, do the same that you can do in standard Postgres tables, where your column becomes a function. So all these different options exist, so you can actually support that kind of use case.
Okay, and another question related to column store indexing. Is there a limit to the number of columns that can be added to a column store index?
Yeah, here we are we're limited based on Postgres standard indexing API. So there's 32, which so far in the field we've seen to always be sufficient. Plus you can actually create multiple column store indexes, each being then 32 columns wide. Generally, we do not see this as an issue, but there may be specific cases in which you may have to create multiple ones that are then next to each other, so to say.
Okay. Question for Hans. Somebody asks whether, when you're talking about migrating from Oracle, can that include Oracle Exadata? Is this an alternative for Exadata or just Oracle?
Yeah. So we are pretty agnostic. It's not just the standard Oracle database. It can also be some Exadata system. So yeah, we can do that, certainly.
Super. Another question for Thomas. Somebody asks whether this requires an FPGA hardware.
Yeah, we get this question a lot. So it's true that Swarm64 has started with FPGAs. In the past, we have since moved away from the strict necessity of an FPGA, so you can run actually all that on a standard server, which is recommended anyway as the path start. So yeah, you do not require an FPGA to run Swarm64.
Okay, and let's see, I think just one more question now before we wrap up. What is the licensing model for on-premises? Is it based on number of cores, like Oracle, or something else? And Thomas,
I'll start, and I'll let Hans talk a little bit about PGEE as well, PG Enterprise Edition. So licensing model is based on the actual cores visible to the system. Quite simple. If you're familiar a little bit with Oracle licensing, you will find that you sometimes have to refer to the small print to actually find out how many cores something corresponds to. Swarm64 is quite simple in this aspect. We also have it openly on our website. We do charge $33 per visible core per month if you take Swarm64 on its own. Yeah, and it is public pricing. This is our list price that's available for everyone. Makes it into a very cost-effective offering, as we've discussed in this slide deck extensively. Maybe Hans, you want to talk a little bit about PGEE?
As far as Postgres Enterprise Edition is concerned, it's also a per core licensing, which is of course a small fraction of what you would pay for Oracle. The same is true for support. The same is true for of course all the rest. And as I said, the Swarm license is included in the full Enterprise Edition. So there are no extra charges for Swarm. So everything is included in our pricing.
Thank you. All right, since we're near the top of the hour, I want to wrap up. If you have additional questions for Thomas or Hans, you can see their contact information there, or visit swarm64.com or cybertech.at for more information on either product. We hope you enjoyed the webinar today and learned a lot from it. I want to thank you all for attending, and also thank Thomas and Hans for sharing their expertise. And we look forward to seeing you online at a future event. Thanks, everybody.